Hello, Algebra 2. Tonight's topic is day 6. We have 3 topics in our notes: compositions, inverse, and quadratic formula. However, this video is going to be focused on the second page of the notes, and that's on inverses. I did write in here on the top of your notes the 3 essential questions for these notes, and they're by page. So for page 1, this is our essential question: what does composition of functions mean and how to find it? Page 2 is how do I find the inverse of a function algebraically and graphically? And then page 3, our essential question is, can I simplify radicals after using the quadratic formula? So again, this video is for page 2, and it's how do I find the inverse of a function algebraically and graphically. This is the video that we want you to watch tonight. We will be practicing all 3 topics in class tomorrow, and if you still have confusions after class, then please go back and watch the videos about composition and how to use the quadratic formula. Okay, so tonight is review of inverses, and remember, when you're reviewing inverses, we can find them both algebraically and graphically. So first we're going to find our inverse of our function algebraically. And remember those steps. So there were 4 steps, and I start off with 3, but I think if I separate in 4, that will help you a little more. So the first step I'm going to call is changing f of x to y, or it could be g of x or h of x. But just remember that f of x or g of x or h of x is y, so that would be our first step, changing f of x or g of x to y. Okay, so just to save time, I went ahead and wrote that and down while we were gone, so I might be doing that off and on as we go. Our second step is switching x and y, and this goes the same when it comes to when we're graphing as well. So we're going to switch x and y. Okay, and our third step is solving for y. And our last step, our fourth step, is replacing y with the inverse notation. And remember, the inverse notation is a -1, and it gets placed in between the function notation. So it would be f of -1 of x, or g of -1 of x, or h of -1 of x. Okay, so just went ahead and wrote that in with inverse notation, and then see where the -1 is here, between the f and the x. Sometimes the directions will just say find f of -1 of x, and you need to know that means inverse. So sometimes it'll use the words inverse and other times the notation. So make sure when you see that -1 in between the f and the x, that means inverse notation. Alright, let's try problem number 1. Okay, and let's do it over here to problem number 1. Our first step, again, is going to be changing our f of x to y. And then, so that's step 1. Our second step is switching x and y. And let's go ahead and use a different color to show you. So just the x and the y are going to change. Nothing else changes. The 3 stays here, the -6 stays here. So the x, the equation becomes x equals 3y minus 6. So only the y and the x switch. That's step 2. Step 3 is solving for y. So to get y by itself, we're going to add 6 to both sides. X and 6 are not like terms, so we're going to keep them separate. And that was going to now be equal to 3y, because -6 plus 6 is 0. We're still, we have a 3 times y, so to get the y by itself, we'll have to divide by 3. because 3 divided by 3 would be 1. And we have to divide everything by 3, both sides, everything. Whatever we do to one side of the equation, we have to do to the other. So this side would become y, and each item here is going to be divided by 3. So remember, when there's nothing in front of the x, there really is a 1 there. So 1 divided by 3 would be 1/3 x, and 6 divided by 3 is 2, so that's plus 2. So there is pretty long step 3, solving for y. Our last step, step 4, is going to be replacing y with the inverse notation. So in this case, we do have f of -1 of x, so that's what we're going to replace y with. The other side stays the same, and that's just showing that you found the inverse and you understand what it means. That's why we have to write that notation. Okay, let's change colors and do number 2 now. So number 2, in this case we have g of x equals x squared minus 2, so my first step is to replace g of x with y. So here's my step 1. I'm doing it as I write it down. My step 2 is switching x and y. And again, only the x and y move. So that exponent has to stay here. It has to wait for the y to come back. Everything else stays in the same place. So just the x takes y's spot and y takes x's spot. Now we have to get y by itself. So to get y by itself, we have to add 2 to both sides. And that would make that 0. That would be the first step. And then we have x plus 2 equals y squared. And now y is still not by itself. It's y is being squared. So just like we talked about in solving radical equation notes, we have x squared. In this case, we have y squared. So we're going to get y by itself, we have to take the square root of both sides. So that makes this y, and then remember, when you take the square root of both sides, the side on here we could be plus or minus, because remember, the minus the square root of x plus 2 times minus square root of x plus 2 would be the original x plus 2 plus positive x square root of x plus 2. So that's why it's always plus or minus when you're solving in this direction. That's our step 3 in this case. We got y by itself. Now we're going to do step 4. And that's going to be our inverse notation. In this case, we have g of x, so it would be g of -1. Okay. Is equal to the positive and negative of x plus 2. Okay, I want you to go ahead and try number 3 by yourself. We have h of x. Go ahead and walk through these steps by yourself and see if and check your work here and come back. So try it on your own first. Okay, for number 3, your first step was changing h of x to y. So you have y equals x minus 2 cubed. Then you're going to switch x and y. So it became x equals y minus 2 cubed. And remember, everything else stays the same, only x and y switches. Now what's in the way is this cube. And we can't change this. We can't do anything here. We can't distribute that cube. These two are together at y minus 2 cubed. So the only way to get to that y is we have to take the cube root of both items. And that would cancel the cube. So this side would become y minus 2, and this side becomes the cube root of x. And now to get y by itself, we add 2 to both sides, and we get y equals the cube root of x plus 2. Last step is replacing y with the inverse. In this case, it's h to the negative 1 of x, and that equals the cube root of x plus 2. So I went ahead and circled all my answers. There's my inverse for g and my inverse for f. Okay. Now we want to talk about how the graph of a function, how it's related to its graph of its inverse. And I want you to remember that it reflects over the y equals x line. So remember that the graph of its function is related to the graph of its inverse by reflecting over the y equals x line. So go ahead and write that down. And then what I want you to do, I want you to graph the function and its inverse on the same coordinate plane. So number 1, you'll graph the f of x and its inverse here. And then number 2 for the g of x, and then 3 for h of x. And the color scheme I'd like you to use, because that's what I'll be using, is the red line. I want you to graph your y equals x line. And then with blue, if you have a colored pencil, please use blue for the original function and green for the inverse. So go ahead and pause and try that. Graph them on your own and then check your answer with me. Okay, so how'd you do? Did you use your y equals mx plus b to graph your lines and your transformations to graph your other functions? Hopefully. Let's see. Let's first talk about number 1. And so our blue line, our function had a negative 6 of a y-intercept, and then a slope of 3. So we started at the y-intercept and went up 3 over 1 for the rise over run, and then kept going to graph our blue line. Then our inverse was 1/3 x plus 2 with a y-intercept of 2 with a slope of 1/3. And so we start there on our y-intercept and rise over run. And we should confirm that it does visually look like it's reflecting over the y equals x line. Also want to look at some points in case it's graphed for us and we have to find the inverse graphically. Then you would take points out of your line and switch the values x and y, just like we did algebraically. So if I look at this point on my blue line, we'd have 2, 0. So when I would graph the inverse, I would plot 0, 2. Also, another point to look at would be the y-intercept, and that would be 0, negative 6. So on the inverse, I would switch x and y and we get negative 6, 0. So that looks good. It looks like I graphed that right and found the algebraically inverse correctly. Number 2 is our parabola, and our blue function in our original function, it was our k moved down 2, made our parent graph move down 2. So notice our parabola is our parent graph is down 2. And then our inverse, I use transformations as well to graph it. Our green is a square root, and it's left 2 because it's plus 2 inside. And then the positive version goes up, and then the negative would go down. So using transformations. Again, look at points to switch. So 0, 2 on my blue should be at 2, 0 on my green. My third function is the cubic, and my parent function of my cubic move to the right 2, and my cube root moved up 2. And again, you can verify doing that. My last step, I want you to go ahead and look at how an inverse is verified. And you verify an inverse by doing composite functions. And a composite of a function and its inverse should be equal to x. So go ahead and try these two. If you're confused with composite, there's another video to watch for that. So here's the work. I verify that I did do that correctly. They